So the big picture for this lesson is modeling data. In this case, we have height and weight, and I'm assuming this is metrics, height in centimeters, weight in kilograms. So what we're going to be doing is using the calculator to do different models, linear, exponential, and quadratic, and then comparing them to see which one is actually the best fit for the data. So I already entered everything into the calculator. You can see here. So now we just need to do the modeling. So I'm on the main screen, and I'm going to go to Stat, Calc, and I'm going to do linear regression first. Enter. So we have y equals ax plus b. The a value is about 1.02. The b value negative 105.5, roughly, or 0.6. And the correlation coefficient is 0.78. All right, so that's the linear model. So now I'm going to try the exponential model. That's exponential regression. Whoop, too far. Exponential regression. Enter, 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 enter. Okay, there you can see the exponential model. Y equals AB to the x. A value is 6.7. B value is 1.01. Correlation coefficient 0.78. So very close to the linear model. Now let's do the quadratic regression. So I'm going to quit. There you go. Stat, Calc, and then quad regression. Enter, enter, enter. Okay, so y equals ax squared plus bx plus c. A value is very small, negative 0.018. The b value and the c value, you can see those. And the r squared is 0.626. They don't give an r value for the quadratic for some reason. So what you have to do is take the square root of this to actually figure out what the correlation coefficient is. And that is 0.79. So all these models are very close. The quadratic model fits slightly better. I mean, we're talking about hundredths of a decimal point for the correlation coefficient, but it does fit slightly better. Okay, so let's take a look at the graph and see how that looks. So remember, to do that, you want to go y equals, and then go to variables, and then we want to go to statistics, and then over to equation and regression equation. So let's look at the graph. And we're going to need to adjust the window quite a bit here, I think. So the x max, I'm going to put at about 200. And the y max, I'm going to put at about 100, just to match the data. Okay, so in this case, the parabola is upside down, and we're kind of getting the curve, I know it's kind of maxing out. Now, the problem with this model, let me change the x max, put it on 500. Okay, now there is a problem with this quadratic model. And remember, the data represents height versus weight. The height increases, the weight should typically increase. Well, this isn't really a good model for the actual situation, because as height continues to increase, the weight is not going to start decreasing. And you have to think about these things when you're doing modeling for mathematics. You have to think about the context of the situation. So you can't just go by the correlation coefficient in this case, because that would lead you to a model that ultimately wouldn't work over the range of the data. I mean, if you were to continue the pattern on, this is a bad model. So that would leave you with either the linear or the exponential. So I think actually in this case, I don't think that height and weight is going to have an exponential relationship, especially when you get larger numbers. I mean, eventually that model is going to blow up too. So I'm going to go with the linear model. Okay, now let's look at the graph for that one. So clear that one out, and then variables, then statistics, then over to the equation, and then regression equation. enter graph. Now this one has a problem too, because if you look at where the x-intercept is, that doesn't really make sense that you're going to have a height and then a weight of 0. So let's assume that is around 100. You're not going to have a height of 100 and then a weight of 0. So this model doesn't work very well either. That leaves the exponential model. So here's the exponential model. I went ahead and graphed it. And I think this is probably the most sensible model to use, just based on the shape of the graph and where the intercept is on the y-axis. That seems pretty reasonable. So in this case, the exponential model is the best model. So the model is going to be y equals 6.71, let's say to the nearest hundredth, times 1.01 to the x power. So that's the model we would want to use to try and make predictions if we were going to use values that were outside of the data points that were given. So that's what you're going to be doing in this lesson. You're going to be comparing different models, the correlation coefficient, and deciding which model is the best one to use. And that's the big picture.